Good afternoon, folks. This is Mike coming back at you with another video on Intro to Algebra. In the previous video, we spoke about the adding property of equality and how we can use that property to help us find solutions to linear equations in one variable. In this video, we're going to look at another property that can help us find solutions to linear equations in one variable, and that property is the multiplication or the multiplicative property of equality. So I want to go back to the idea of thinking about a scale. Again, we have our scale where the plates on two sides are balanced evenly, and I have some quantity of weight there. Here we have our weights. So from the previous video, we said if we added or subtracted any quantity of weight onto one side, we had to do the same to the other so that the scale here would stay balanced and things would stay equal. Well, multiplication is really just another way of adding the same thing onto itself a certain number of times. And dividing is really a glorified way of just subtracting the same thing from something some number of times. So if I take the quantity of weight that I have here and I multiply it by some quantity, then obviously I have more weight on this side. Scale is going to go down, which means that side is going to go up. But again, the whole point is to not have the scales be uneven. We want them to be even. So what I did to one side, that is to say I multiplied the amount of weight that I had on one side by some number, I have to do the same on the other side. I have to multiply this weight by that same number. And when I multiply, those scales will go back to being even. They'll be perfectly balanced, and things are going to be equal. Note that my scale is not drawn to scale. Terrible joke. There's a reason I majored in math and not art. Similarly, if I reduce the amount of weight that I have on one side, like say that I took half of this weight off and put it down to there. Well, now, again, there's more weight on this side. That side's heavier, so that'll go down, and that'll go up. But, again, we don't want that. We want the same amount of weight. So what I did to one side, that is to say, took off half of the weight that I had to take off half of the weight that I have on this side as well. So now things are balanced, now things are equal, and we don't have one side being higher or lower than the other. So this is very similar to what we did in the previous video, but we're just doing a slightly different operation to our weights here. So what does this mean in terms of linear equations in one variable? Mathematically, what we're saying here is if a, b, and c are real numbers, so long as c is not 0, then these two equations are the same. A equals b, and a times c equals b times c. But don't worry with the technical mathematical statement of it. Really what you have to focus on is really what it's saying informally. And informally, what it's saying is that you can multiply or divide each side of an equation by the same number at the same time, and that resulting equation is going to be the same as what you had. You're going to have the same solution or solutions as what you had before. And this all just goes back to what we said from our previous video, which is what you do to one side, you have to do to the other at the same time. There's a common theme here of doing the same thing to each piece of your equation, being fair, being balanced, being equal. So let's do some samples here. 2x is equal to 12. And again, the whole point here is to do something so that we just have something of the form x equals and then some number. So x equals blank. So here I see that I have 2x is equal to 12. So what can I do what can I do to this left-hand side here so that I don't have 2 times x, I just have x? Well, if I divide this side by 2, then I have 2 divided by 2. Those will divide out to 1. And then I'll just have x. Perfect. But, as we said, what you do to one side, you have to do to the other. So I have to divide the right-hand side by 2 as well. And that gives us 12 over 2, which is 6. So x is going to equal 6. All right, next one here, a little bit more perhaps visually challenging. 2/5 times x is equal to 1/2. All right, so again, I have some number times x. I just want to get x all by itself on that left-hand side. So if I have something times x, I can divide by that coefficient. I can divide by that number in front of x. And I know that when I divide these out, that is going to give me just 1 there. And then I have 1/2 divided by 2/5. The left-hand side was just x. But now think back to chapter 1 where we said that we can not divide by a fraction, but we can take that division and change it into multiplication. How do we do that? We multiply by the reciprocal of that second fraction. We multiply by the reciprocal of the fraction that we had on the bottom. So 1/2 divided by 2/5 is the same thing as 1/2 times 5 over 2. And if you do 1/2 times 5 over 2, you get 5 over 4 by just multiplying the bottoms and the tops. The third one I'll let you solve on your own. Going on to the fourth one here, -7 over 4 times x is equal to 6. Again, this is very similar to the one that we just did. I have -7 over 4 times x on the left-hand side. I just want x, so what am I going to do? Divide by the number that I have in front of x. Divide by that coefficient. And then what I do to one side, I have to do to the other. These will divide out to 1. So x equals. Now again, we're taking a number and we are dividing it by a fraction. But we don't want that. That's ugly. That's gross. That's bad. So instead of dividing by a fraction, let's multiply by the reciprocal of that fraction. So x is going to equal 6 times 4 over -7, or -4 over 7. All means the same thing. So I have 6 times -4 over 7. And think back to one of our previous videos. We said that a whole number or any integer is like saying that thing over 1. So multiply the tops, gives us -24. Multiply the bottoms, gives us 7. So x is equal to -24 divided by 7. So guys, that concludes our video here on the multiplication or multiplicative property of equality. If you have any questions or comments, please be sure to reach out to me, guys. Send me an email, give me a buzz on the phone, stop into my office, whatever you need to do. Otherwise, until the next video, take it easy, guys.